Welcome everyone. In this video lecture, we will solve a MOSFET circuit based problem. So basically, this is just a continuation of the earlier problem. So here the question is, we have to redesign the circuit. So we have to redesign the circuit, okay, with the following requirements. So the given things are VDD value is given. It is our 5 volt. The drain current ID is given. VS 1.6 volt. Thermal threshold voltage 1 volt, K and S W by L 1 milliampere per volt square, VD value 3.4 and 1 microampere current flowing through this one. Okay, so these are the things are given, and also the transistor is in the saturation region we have already discussed in the earlier uh, problem. Okay, so the thing is that here we have to know the value of RD, RG1, RG2 and RS. So we have to find, basically we have to find the value of unknown parameter. So the thing that we have to find, that I am writing here for RG1 we have to find, RG2 we have to find, we have to redesign the circuit. So means these are the parameters which are unknown, we have to find. RD value we have to find, RS value we have to find. In addition to that, the gate voltage is also unknown. So this VG also we have to find. So basically this one is not known to us. So basically we have to find all these parameter. Okay. So first of all, the ID value is given. This one is given, the ID value, and this one will be also ID, and some current is flowing in this one loop is the 1 microampere. Okay, 1 microampere in RG1, RG2. Okay, and there will be zero current, so no need to 0 ampere. Okay, so now first I'm just going to find the value of RD. Okay, so for RD what we can do, simple network concept. VD is 5 volt and this VD is given, VD is known to us 3.44 volt already given, and this ID we are known to us that is our 0.32. Okay, I am writing 0.32 milliampere. Okay, milliampere. ID we have to find this RD. So by using simple network concept, or simply we can write RD equals to higher potential, that is a VDD minus VD divided by simple ID. Okay, VDD minus VD by, so it should be our VDD is 5 volt. Okay, in the old problem it is 10 volt, now it is given 5 volt, so we have to take 5 volt, and VD is 3.4 volt, and this one is ID is given 0.32 milli. So one can write this 5 minus 3.4, that much simply 1.65, 0.32 into 10 to power 3. So RD value, if we solve this one, it should be simply 5. Okay, so 5 and 10 to power 3, so better to write kilo ohm. So RD value will be now known to us 5 kilo ohm. Okay, so I am highlighting this, but this is the one of the parameters. So RD value we have already find by using this concept. Okay, RD. Okay, now RD is known to us. Now we have to find the RS value. Okay, so for RS, what we will do? Again, I am just selecting first pencil, then RS. Okay, and this value is given VS 1.6 volt, and this one is connected to ground, so 0 volt. Okay, simple 0 volt, and RS, and this current will be our ID. The same current, no current will go to this direction, all current will go like this. So now the RS value, higher potential, that is our VS minus 0 volt ground potential divided by ID. Okay, so Vs is simply 1.6 volt. Okay, so 1.6, ID 0.32 milli. Okay, so one more line I am writing 0.32 into 10 to the power 3, so it should be again 5. So 5 kilo ohm. So the RS value is now 5 kilo ohm. So RS is also same as that of RD. Okay, so this one is one thing. RS is also, so RSRD is now known to us. Now what we have to find the value of RG1 and RG2. Okay, so now here gate voltage we have to find what should be the gate voltage across this. So this gate voltage for calculation of VG, okay, I'm writing VG calculation we are doing in that side. So for VG calculation what we can do, we have to just go from the drain current equation in the saturation region. The device is in the saturation region. In the earlier, means in the last problem we have already discussed. So ID value will be 1 by 2 times of K and S W by L VGS minus VT whole square. This is a standard ID drain current equation in the saturation region. This one is in the saturation. Okay. So now next what we will do, ID value is known to us, that is our 0.32 milli. So 10 to the power minus 3. This should be half into 1 milli. So 10 to the power minus 3. And VGS, better to write full, VGS minus VT whole square. So this cancel. Then 0.64. Okay, after multiplying with 2, VGS minus VT whole square. Now next, what we can write, 64 by 100 VGS minus VT whole square, or simply we can write this as a 8 by 10 whole square, okay, or 0.8 whole square, okay. So one can simply write VGS minus VT value will be 0.8. So VGS value, get to source value, will be VT plus 0.8 volt. Okay, VT is given 1 volt, so 1 plus 0.8, so 1.8 volt. Okay, VGS value will be 1.8 volt. So now this one is VGS. VGS is 1.8 volt. So this can be also written as VG minus VS. Basically, we have to find VG. So one can write VG minus VS equals to 1.8. Okay. So the VG value will be 1.8 plus VS. So 1.8 plus VS value is known to us. VS is 1.6. So 1.6. So it should be our 1.6 3.4 volt. So now the VG value will be 3.4 volt. Okay. So now the VG value is known to us. Okay, I am highlighting this one is the important result. So better to highlight 3.5 volt, and it is coming from this equation. Okay, like that we are solving. Okay, first we have find VGS 1.8, then we are writing this. Okay, then we have already find VG 3.4 volts. So now VG is now known to us. Why we have find this VG? Because we have to find RG1, RG2, and the current in this path is 1 microampere. So I am just drawing the circuit here for the RG1, RG2 calculation. Okay, better to take black color. Okay, this one is VDD, that is our 5 volt. This one is RG1, RG2, and this one is grounded, and this one is VG. Okay, gate voltage. So now gate voltage is 3.4 volt. Okay, and this whole current in this loop is 1 micro ampere, that is known to us. So now what we will do, we can redraw the circuit like this. That is VDD, RG1, RG2, and this one is grounded. this value is Vg is around or exactly 3.4 volt, and this VDD is 5 volt. So this means this voltage is 5 volt. Okay, VDD. Okay, so and the current in this one is 1 microampere. Okay, so Rg1 value, the value of Rg1 value can be calculated as VDD minus Vg. Okay, this one is Rg1. Okay, so this potential we have taken VDD and this one is Vg. So RD Rg1 equals to VDD minus Vg by Rg1. Okay, so simple network concept. So 5 minus 3.4 by, okay, not Rg1. This should be our, okay, sorry, there is a slight mistake. Rg1 we better to write VDD minus Vg by I. This current is say I current is flowing in this one. I current 1 microampere. So it should be 5 minus 3.4 by 1 micro. So 5 minus 3.4 is 1.6, and this micro will go up to 10 to the power 6. So 1.6 mega ohm, sorry, mega ohm. So Rg1 value will be 1 mega ohm. Okay, similarly for Rg2, for Rg2 value will be Vg minus 0 by I. Okay, so Vg is 3.4 minus 0 by 1 micro, so 3.4 mega ohm. So here I am writing once again. So the Rg1 value will be 1.6 mega ohm and Rg2 value will be 3.4 mega ohm. Okay, so like that we can solve this problem. Okay, Rg1, Rg2. Okay, and we have just know this value Vg 3.4 from this equation, drain current equation in situation. Then Rg1 value and Rg2 value we have find. So like that we can solve the each parameter for this question. So here the now the final result, or we can say the final answer for, I am writing here Rg1, what we are getting, we are getting 1.6 mega ohm. Okay, mega ohm, and Rg2 3.4 mega ohm, Rd 5 kilo ohm, Rs 5 kilo ohm, and Vg around 3.4 or something, no? Vg 3.4. Okay, 3.4 volt. Okay, so these are the design parameter, we can say. Okay, so these are the design parameter for this question. Okay, 3.4. Okay, so this is all about this question. So thank you for watching this video.